This is part 2 of homework 2, solving rational equations. A rational expression is a quotient of two polynomials, usually written as a fraction. So it looks like these, okay? Because division by 0 is undefined, the denominator of any fraction cannot equal 0. So basically, if it has an x in the denominator, then we have excluded values because it's going to make, if x was 0 here, it would make it undefined. Same thing here. So in this particular case, we have to do our restrictions, is what I'm going to call it. For now. Later it's going to become the domain, and it's not going to be written quite like this. So x cannot equal 0. What you can do is you can actually take this, set it equal to 0, and solve. Whatever it happens to be, whoops, let's not divide by x, let's divide by 2. And x, 0 divided by 2 gives us 0. Okay, so x cannot equal 0. Here, to find your restrictions, you can take x plus 3 and set it equal to 0 and solve. You subtract 3 from both sides. And x cannot equal a negative 3. So x can be anything but negative 3. Always keep your restrictions in mind, okay? Let's put not equal. Okay, so we want to get rid of, okay, so, oh, by the way, and if our answer came up, when we go to solve this and we come up with x equals 0 in this, this is known as an extraneous solution. So that means we'd have to kick it out, and we would have to kick that answer out. If it was our only answer, it would be no solution. If we had two answers to this problem, but only, and one was 0, we just kick that out, and it'd only be the other problem, which we'll get to. Okay, so nobody likes to work with fractions if they don't have to. So what we're going to do is we're going to get rid of our fraction. Now, to get rid of your fraction, what you all have to do is multiply by our least common denominator. Okay, so we are going to find our LCD. Now, this one's going to be different than these, okay? So first of all, right here, 2 and 4, they both will divide evenly into 4, and then we also need this x, okay? Because again, that's something else. Now, will 4 go into 4x? Sure. Will 2x go into 4x? Yes. And will x? Yes. So that is our LCD. Now, what we're going to do with that LCD is we are going to multiply each one of these factors by that 4x. Now, I usually don't do it like this. I only do it like this when I'm teaching. I always tell my students, if you have trouble with this, write down all your terms. Okay? And what you're going to do is you're going to multiply each of these terms by your LCD over 1. Now again, this isn't how I work it. But then again, I can do things in my head where some of you really need to do it on paper. Now you multiply straight across and you reduce. Okay, again, most of you will say 9 times 4x is 36x. 4 times 1 is 4. And then you're going to simplify that to 9x. Okay, I do it like this. I simplify first. As long as one's in the top, one's in the bottom, I can reduce within the problem. So 9 times 1 or 1x is 9x over 1. So this here, when I multiplied by my LCD, I got 9x. Then I'm going to have minus. Then I'm going to go over here. And again, you guys will probably do 4, multiply straight across. 1 times 4x is 4x, 2x times 1 is 2x. And then this is going to divide and give you 2. Okay, your x is canceled. 4 goes into, or 2 goes into 4 2 times. So I end up with 2 there. And then over here, I'm going to get 16x divided by x, which just gives me 16. Again, I cancel like this, and 4 times 4 is 16. Here, I would go 2x goes into 4x 2 times. Either way, it still gives us what we have here. Now, this gives us 16. See, now we went from something that looks really difficult to something that is pretty easy, or it should be easy. We're going to add 2 because our variable's on the left, so we're going to take our constants to the right. We're going to add 2 to both sides. That gives us 0. We get 9x equals 18. Divide by 9, and x equals 2. Okay, again, these are ones that I really tell you to go ahead and check your answer. Okay, there's actually, I think there's 4 different types of, or 5 different types of equations that we will check throughout the semester. What happens is, sorry, I've got a glare from our light in our office. A lot of people will forget to do this. Okay, so if you forget to do this and you end up with 0, if you check your answer, it's going to give you an error message. So again, I'm going to just check it. X store, let's try this. 2 store x, just like we were earlier. I'm not going to use my fraction key. I might as well. Well, some of you don't have it, so I would do it like this. It's just fastest for me. Parentheses 9 divided by 4. I just like it in parentheses. Minus 1 divided by the problem with this is you probably should always put it like this. Whatever's in the bottom, if you have more than one thing in the bottom and one thing in the top, you should put it in parentheses. Okay, that's going to give you 2. If I did 4 divided by 2, it's going to give us 2 as well. So 4 divided by x, it gives me 2. And then again, this one probably, if you've got the fraction key, the F1 key, you probably should do it like this and do 9 fourths minus alpha F1 1 over 2x, and then you get 2, and then the 4 over the x, same thing. I'm really lazy about it, sorry. And then 4 divided by x, and you get 2. So the left equaled the right, and it was fine. Checking these just in case you forgot to do this. Okay, so here we have x equals a -3, and what we've got to do is find our LCD. Okay, now if you look at some reviews that I've done, and they're old reviews, I don't do this over here. What I do is I put times my 4x here, because that was my LCD, times my 4x here, times my 4x here. And the reason I do it like that is I can say 4 and 4 cancel, so I have 9x. 2x goes into 4x 2 times, so 1 times 2 is 2. And then x goes into x 1 time, so 4 times 4 is 16. So you will see me do this and sometimes in my work. Okay, so we're going to find our LCD. Oops, let's leave it in red. Now when it gets like this, it gets a little bit more difficult, but it's still not hard. Now this has a denominator of 1. To find your LCD, your least common denominator, is you take your first denominator, x plus 3, and you write it down over here. Then if you have any other denominators that are different, you tack those on. This is a 1, so I can put times 1, but it's not going to change anything. So then I go to the next one, and it's an x plus 3. We already have one. So we found our least common denominator. So what we're going to do is we're going to multiply each of these times that x plus 3. So we have x plus 6 over x plus 3, 2 over 1, or just 2. I don't really need the 1. And 3 over x plus 3. So I'm going to multiply this by our LCD, which is x plus 3 over 1, this times x plus 3, and this times x plus 3 over 1. And this goes together like this, okay? That way they look alike. Your x plus 3's cancel to give you 1, and you get just x plus 6. See, this is the exact same thing that I'm doing right up here. It's just with these type of expressions, I should say, x plus 3 and x plus 3. Here, 2 times x is 2x, and 2 times 3 gives us 6. Now we got to be careful here because there's a minus sign in front of it. I personally look at this as a negative 2 over here, but a lot of you won't, so I'm just going to, for now anyway, you're just going to leave it like this. If you do, that's fine. Here my x plus 3's cancel, and I just get 3 over 1, which is 3. So now, here I have x plus 6 minus this 2x plus 6. Be careful there. Anytime you have subtraction, you got to be careful. And here I ended up with just 3. Okay, so now when we simplify this, we get x plus 6. We're going to distribute this negative, and we get negative 2x minus 6 equals 3. Okay, so if you're to look at my work and I have something that looks like this, where I'm multiplying all the x plus 3's here, it's the exact same thing that I'm doing over here, but I just go like this, and I get x plus 6. Now I would read this as a negative 2, so when I say negative 2 times x, I get negative 2x. Negative 2 times 3 gives me negative 6. And then here, this cancels to give us 3. Okay, so now I'm going to combine my like terms before I start moving anything. That gives me a negative x. 6 and negative 6 gives me 0 equals 3. I'm going to move that over towards the equal sign. Now, I don't want to know what x is. I want to know what a negative x is. I need to know what an x is. So this really has a negative 1. So you're going to divide both sides by negative 1, and we get x equals a negative 3. Now, at this point when I have negative x equals 3, I could, if I change this sign, I just have to change that sign. So either way, it's okay. Now, if you'll notice that negative 3 is one of our restrictions. But let's say you didn't recognize that. If you check your answer, okay, if you go to your store button and say negative 3 store, again, your store button is here. By the way, this is your negative sign, not this. This is your subtraction sign. These are your operations. That's your negative. So negative 3, your store button, STO, and your X. Now, when you go to your fraction key, alpha F1, 1, and you do x plus 6 over x plus 3, and again, negative 3 plus 3 is going to give us 0. Okay, so that would be make it undefined. But again, maybe you didn't see it. Minus, whoops, not plus, minus 2. When I hit enter, I'm going to get an error message. But always read it, because what happens is a lot of times my students, you included maybe, you get what I call clear happy. You go, oh crap, I got a mistake, I've done something, I've plugged it in, and then you start plugging things in all over and you still get it. But read your error message, divide by 0. Okay, well, that's because we can't do that. Now, it's not going to tell you that it's undefined. It's just going to tell you that you can't do that. Now, you have two choices anytime you get an error message, even if it says syntax. Now, if it says syntax, you've done something wrong. Okay, you might have used a plus, then a divide sign right after each other. Okay, or plus minus or something like that. Just something, just you hit the wrong button. Now, you have a choice to quit, or you have a choice to go to it. I always go to it because it may flash over what I've done wrong. In this case, it flashes over that, but I don't really know why it flashes there. Hold on just a second. Let me see. I want to go to it. Oh, I don't know why. Usually it will flash here. Okay. I didn't really need to do that because I knew it was going to divide by 0. Okay, so all right, I'm still getting that divide by 0, so that didn't really, the go to didn't really help me other than it gives me an error message. But then if I check the right hand side, this side, you'll notice that the same thing happens because of our denominator. Okay, when I plug in -3 here, -3 plus 3 gives me 0, so I'm saying 3 divided by 0, which is undefined. And it gives me that same divide by 0. I can't do that. Okay, see, that actually did it, you know, put it at the end. Maybe it did it before because it was at the end of where we divided by 0. Anyway. Okay, so what do? So with this will not work. Because it was our only answer, we're going to write no solution. There isn't a number out there that is going to make this a true statement. There's not a number out there that x can be that the left is going to equal the right. Okay. Number 9, got 2 more. We have 2 more. Okay. First thing I'm going to do is I'm going to factor this. Okay, this is going to factor as 3 times x plus 5. Okay, so again, what we're going to do is we've got to find our GCF. Okay, I'm sorry, our exclusions first. Let's do that. So here, x cannot equal -5. Okay, same thing here. If I set this 3x plus 15 equal to 0, and solve, I get 3x equals, if I take that over there, -15, I'm skipping steps and divide by 3, I still get x equals -5. Okay, so now to find our GCF. What I do is I take my first denominator and write it down. Then I go to the next denominator. Do I have a 3 over here? I do not, so I need to tack that on. It can be in the front or the back. It doesn't really matter. I just like it in the front. Okay, you can put that 3 here. Then this has a denominator of 1, so we don't need the 1 over there because 1 times 3 is 3. The 1 just, when multiplying, just doesn't give us anything. Okay, so now we're going to multiply by our GCF. Every single time to get rid of fractions, you multiply by your GCF or your, GCF. Am I saying that right? For some reason, it just doesn't sound right. Greatest common factor. Actually, it's probably our LCD. I've been teaching it wrong the whole time. Yeah, oh, no, I didn't. Whew. I just drew a blank on this one. LCD. I don't know why I went to GCF. If I said it before, sorry. Somewhere along it. Okay, so I knew that wasn't right. I don't know. It's been a long week, even though we've been out. Okay. So we're going to multiply by our LCD, just like we did before. So again, if you need to, go over here and write down all our terms, just like we have over here. And I'm going to write it like this: 3 times x plus 5. And then my 3. So I'm going to multiply this by this, or LCD over 1. And multiply this times 3 times 3. Oops. Let's try this again. This times our LCD. Now here, our x plus 5's cancel, and we get -21. Here, our x plus 5's cancel, our 3's cancel, and we get -4. Here, 3 times 3 gives us 9. 9 times x is 9x, and 9 times 5 is 45. So, at this point, we get -21 equals -4 plus 9x plus 45. Now, sooner or later, I'm not going to do this, okay? I will do my shortcut like this because To me, this is a lot of rewriting stuff that I don't need to do when I can do this like this. But I will to begin with. Okay, here these cancel, I get negative 21. 3's cancel, x plus 5 cancel, so I'm left with negative 4. 3 times 3 is 9, 9 times x is 9x, and 9 times 5 is 45. Okay, now we're going to finish this problem out. We get negative 21 equals 9x plus 41, because I'm combining these two. Now, my variables are on my right side, so I'm just going to go ahead and move the 41 to the left side by subtracting it. And I get 9x here, and I get negative 62 here. I'm going to divide by 9. But 9 will not go into 62 evenly, okay? So you don't want to change it to a decimal, and I don't want any repeating bars. We don't do that in our class, okay? Just bring it down as negative 62 over 9. It won't reduce, you'd want to reduce it, but not to a mixed numeral, okay? If we had this and we hit math 1, it will reduce our fraction if it will, but it won't. So just leave it like that. Now, something I didn't do in the beginning, and I don't know if you, oh yeah, I did. Didn't I do the, yeah, oh, it got covered up here. Our restriction, okay, I didn't think I had, but our restriction was negative 5. But sometimes you're going to forget. And if you forget, you still, by checking this, would see that it, you would get that error message, okay, for it being undefined. Okay, I'm not going to probably check this one, but I might, I don't know. Let's see, negative 62 divided by 9. I'm going to hit math, fraction. No, I'm not. Well, it doesn't matter. It makes it, I want to store it under x, is what I was trying to do. By the way, a lot of you do not like using your store button, or you want the store button back the way it came from the factory. Well, you didn't even know, most of you didn't even know about the store button, so it didn't really matter, but 0, it comes from the factory as 0 stored in there. So if you ever want to just clear it out, that's fine, just hit 0 store x. Okay, so now I'm going to put in negative 7 on top, then I'm going to put x plus 5 on the bottom, and my right hand side gives me this fraction here. And it doesn't matter if you have fraction or decimals for your answers, you just want the left equaling the right. So math f1, 1, I'm going to say negative 4 on the top, 3x plus 15 on the bottom, that's fine, you could use this either way, plus 3. Hopefully these two match, and they do. So I know that answer is right. Okay, this one right here, you have to factor this first. So it is going to factor as x plus 3, I'm sorry, y plus 3, y minus 1. Okay, don't worry about how I did that so fast. One thing I am really good at is factoring, and that, again, I'm not good at because I'm just super smart. I'm just good at it because I have practiced so much. Okay, so now we have our restrictions that x cannot equal 1 here, and it can't equal negative 3 here. And here's 1, that one's negative 3. Okay, well, let's try y. I'm so used to using x all the time. Sorry if I change up my variables. On a test, I would not count it wrong if you put an x. Alex, I think Alex is pretty nice in the fact that it'll tell you to use a different variable. So, and you get multiple tries at each problem. So, okay, our LCD, to find our least common denominator, you take your first denominator and write it down, y minus 1. Now you go to your next denominator. Do we have a y plus 3 over here? We don't, so we need to tack that on. And we do that by multiplying. We need to list it as well. We come across a y minus 1, but we already have one here, so we don't need another one. Then we go to this one. We have a y plus 3, but it's already there, so we don't need another one. So what we're going to do is we're going to multiply each one of these by that denominator, or at least common denominator. So we have 1 over y minus 1, y plus 1. Be careful because that's a minus sign there. You always want to be careful because everything afterwards is going to change. Over, I'm going to do it in factored form, y plus 3, y minus 1. And then we have 1 over y plus 3. I am going to multiply each of those by the y minus 1, y plus 3 over 1, y minus 1 times y plus 3 all over 1. And the same thing down here. Okay, these cancel. So I have y time 1 times y plus 3, so I have y plus 3. Here, our y minus 1's cancel, our y plus 3's cancel, so I'm left with y plus 1. And then here, my y plus 3's are going to cancel, and I have y minus 1 right here. Okay, because this is a minus sign, when I distribute, this becomes a negative y, this becomes a negative 1. And again, when I do this, okay, I do it like this just to show it one last time. That cancels, I get y plus 3. Y minus 1's cancel, y plus 3's cancel. I have minus this whole thing, so I would have said negative y minus 1. And then here, y minus 1, y plus 3. Y plus 3's cancel. 1 times y minus 1 is y minus 1. Okay, so here your y's cancel, and I get 3 minus 1 gives me 2 equals y minus 1. Now I'm going to add 1 to both sides. I don't really know why I'm showing my work at this point, but, and I get y equals 3. That was not a restriction, so that is fine, but I'm going to just double check to make sure all my math is right. Okay, it's okay as far as this not giving me 0, same thing here and same thing here, because if I plug in 3, this gives me 9, plus 6 is 15, minus 3 is 12, so that's good. And my calculator needs charging as usual. Okay, so let's just check one last time. 3 store x, 1 over, instead of y, I'm going to use x because that's what we have. We can store things under y, but you have to hit your alpha, and you got to find y down here, which is someplace. It's above, it's actually above the 1, but that's more buttons, so I'm just going to change my y's to x's. Minus x plus 1 on the top, x squared plus 2x minus 3 on the bottom. By the way, this is your exponent key, but we use to the second power all the time. It has its own button. So if you use this, you don't have to drop it down. If you use this button, you're going to have to use your right arrow key, because what happens is it stays up here in the exponent if you don't. So alright, so we got the left hand side, it gives us 1/6. On the right hand side, I don't really need to do this on my calculator, because if I plug this in, I get 1 over 3 plus 3, which is 6. But let's try this again. Put the 1 on the top and the x plus 3 on the bottom. and we get 1/6. So the left equal the right. I know that answer is correct. And that finishes up homework 2.